Good morning, everyone. We can wait for next 2 or 3 minutes for your friends, and then we can continue our today's lecture.
Good morning, sir.
Good morning, Simon.
Morning, Azan.
Morning, good morning, Ahmed. Okay, so now again, good morning to everyone. So now I will continue our today's lecture. So hope everyone can listen me and can see the share screen, right? Just anyone can give me the response, then I will continue.
Just,
Yes, sir.
yes,
Yes,
Sajjad.
Azan.
Okay. Okay, so now let me just little bit recall for first 1 minute. So last week on Monday we did like find the R1's complement. So for both binary numbers and for the decimal numbers, if you guys remember. So we did like if we have a tens complement, like we have a r minus ones complement. So r minus ones means r is the base. So hope you know r is the base. So we can have minus 1 from the base. So like 10 minus 1, it is 9's complement. So when we say r minus 1's complement, it means that we are trying to find if the base is 10. So it means we are trying to find 9's complement. If the base is 2, if the base is like binary numbers, if the base is 2 r minus 1, then in that case we are trying to find 1's complement. Okay, now here is the important thing, like maybe let you give you some shortcut. Okay, shortcut here is like for the binary numbers, only for the binary numbers, how we can verify our this answer is correct. Let's suppose what does it mean, like if we have a this binary number and I says find one's complement. So one's complement means we are trying to find r minus one's complement, right? So and then after that we did this overall calculation. We follow the way what is written in the book. So we follow that way, and then we can see, and then we can find out our result. So it means when our number is like 0 1 0 1 1 0 1, when we have this number, our answer is 1 0 1 0 0 1 0. We have this number. So from here we can conclude one thing, that is shortcut, or maybe we can say the verification shortcut to verify your answer, to verify. So when you have a one's complement for binary numbers, what you guys have to do, just change each bit with opposite. Like what does it mean? It means if you have a number 0, change it to 1. If you have a number 1, change it to 0. Follow this way. Now let me start from here, this side to this side. Our 0, so our it is 1. Then we have a 1, this 1, it means it is 0. Then we have a 0, change it to 1. We have a 1, we can change to 0. We have a 1, change it to 0. We have a 0, change it to 1. We have a 1, change it to 0. So this is your answer. And you can see this answer and this answer is the same. You can see. So this is a shortcut way if you want to verify your answer. So for binary numbers, if you have a number 1, sorry, if you have a 0, change it to 1. If you have a 1, change it to 0. So like here we have a 0, it is 1. Then we have a 1, change it to 0. We have a 0, it is 1. Then we have a 1 1, it is 0 0. Then 0, we have a 1. Then 1, we have a 0. So this is a shortcut way to verify your answer when we want to find out the ones complement. So hope you guys understand this shortcut idea to verify your answer. But in the exam, if I ask you the shortcut, so write shortcut. If I ask you the detail, so this is the detail answer. Okay. So if you want to verify your answer, so you can verify by this way. So you can verify by this way. Okay. So now this is our r minus 1's complement, and this one the topic was diminished radix complement. Next is, sorry, and this is the observation what I explained you. Okay. Now from here, so this is now from, yeah. And another thing, if you want, let's take an example, one more example to verify your answer. This is this is one way shortcut to verify your answer. I mean this one. This is one way. And other way is, if this is the answer, and if in this answer, if you add answer plus this one together, so your answer should be 1 1 1 1 1, so on. How many digits you have? Like if you have a 7 digit, so you will get 7 1. If you sum answer, this answer and this question, if you add both, your answer should be 1 1 1 1 1. How many digit you have? Like here you have a n is 7, so you should get 7 ones. If you not get 7 ones, it means you are trying to doing something wrong. Okay, so here is the way. So now from here, let's take an example. So now example is, we have a, this is our question, this is our question. The question is, you have a 1 0 1 1 0 0 0 0. Now we want to find the ones complement of the question. So ones complement. Okay, so ones complement, the shortcut I just taught you. So 0, it will be 1, 0, it is 1, 0, it is 1, 0, it is 1, 1, it is 0, it is 0, 0, it is 1, 1, it is 0. Now, if you add both, I mean, if you add your question and one's complement together, your answer is 1, 1. So if your answer is 1, 1, it means verified. So verified means the one's complement is correct. Okay. So this is another way to verify your answer. So now you can see, hope you know how to do the binary addition. So 0, 0 plus 1 is 1, 0 and 1 is 1, 0 and this 1, 0 and this 1, 1 plus 0 1, 1 plus 0 1, 0 plus 1 is 1, 1 0 1. So this is your answer. So this is another way to verify your answer. Okay. So you have a two ways. One is directly you can change 0 bit to 1 or 1 bit to 0, and then you can add your answer with the question. So if the answer is 1111, it means your complement is correct. Okay. Next is we have another type which is called radix complement. Okay, it is called radix complement. So now for the radix complement is, what is the radix complement? So it is called the R's complement. So it is called actually R's complement. So it means if the base for the digit is 10, if base is 10, it means we are trying to find tens complement. Okay, we are trying to find tens complement. If we have a base 2, it means we are trying to find twos complement. If we have a base 8, it means we are trying to find 8's complement. If we have a base 16, so it means we are trying to find 16's complement. So now, how we can find now the 10's complement or 2's complement or 8's complement? So general rule is the R's complement of n digit number, means we have a n digit numbers. N is the base, sorry, n digit number n in base R is defined as Rn minus n for n is not equal to 0, as 0 for n is equal to 0. So comparing with R minus 1's complement, we note that R's complement is obtained by adding 1 to the R minus 1's complement. Okay, what does it mean? It means that if you find R minus 1's complement, because you know the way now how to find R minus 1's complement, right? Hope you guys know how we find out the R minus 1's complement. So if you add up just one number, this one, in this method R minus 1's, this one will be your R's complement. This one will be your R's complement. Just you have to add one number. Okay, so that will be your R's complement. Okay, so now based on this one, so we can find out this is the number, and from this number we have to find now the tens complement of this one. So how we can find? Let me go to the next page so I can solve some example. Then let's take this example. Now we can say example. So example is find R's complement of number number 0, 1, 2, 3, 9, 8 have a base 10. Okay. Now the solution for this one is, first how many n we have. So n we have 1, 2, 3, 4, 5, 6. N is 6. Capital N is 0, 1, 2, 3, 9, 8. Okay. So we have this number. Now put in the formula. Okay. Now put in the formula. That is now Rn minus n, right? Okay. Rn minus n. So now our R R is our base. So here R is 10. So now 10 power, how much we have now? N is 6 minus N is 0, 1, 2, 3, 9, 8. Okay. And 10 raised to power 6 means, it means 1. I hope you know this thing, that 1 and follow this one. 10 power n means represent a number that consists of a single 1 followed by n number of zeros. So we have to write 1 and number of zeros. How many number of zeros? Based on that one. So 1 and now n is 6. So 1, 2, 3, 4, 5 and 6. Now minus this one, you can subtract 8, 9, 3, 2, 1, 0. Okay. So the answer is now 9, 8, 7, 6, 0, 2. So this is your tens complement. This is your tens complement. Okay. This is your tens complement. Now we have another way. Okay. For this case, I follow this way, right? I follow this method, that Rn minus n. Now the theory says that we can also find R minus 1's complement, and then we can add 1 if I follow this way. So find R minus 1's complement and then add 1 in that digit. So we can verify this one now. Now let's suppose, now another way, okay? Maybe we can say method 2. Method 2. So this one maybe we can say method 1. Okay. Now method 2 is, we have R n minus 1 minus n, right? And then plus 1. Because this one is our R minus 1's complement. Hope you know. R minus 1's complement. So this is R minus 1's complement. Okay, so then now our R is our 10 power 6 minus 1, then minus n, then plus 1. So we can do now. So we can do 1, follow 6 zeros, 1, 2, 3, 4, 5, 6, minus 1, then minus n, then plus 1. So now we cannot find this one. So now this one is now, so this is now 9, 9, 9, 9, 9, 9, and n is our now, n is our 8, 9, 3, 2, 1, 0, and subtract this one and subtract this one. So when you subtract from here, so you can get 9, sorry, 9, 8, 7, 6, 0, 1. Now the next thing is add this one. Add this one here. So plus 1. So when you plus 1, the answer is 987,602. So now you see this one and this one is same. The same answer. So it means, as I just recall once again, it means if you find r minus 1's complement and just add 1, so you cannot get r's complement. So the people mostly prefer r minus 1's complement because r minus 1's complement is very easy. So then from r minus 1's complement just add 1, so you will get the same answer. So this is the way how we can find r minus 1's complement. Okay. And then hopefully you guys, so this thing you can do, so this thing you can do in your home. So now we will do this binary number. Okay, we will do this binary number. Anyone has a question here? Anyone?
No.
Okay, if you don't have any questions, so then we can move on to the next example. Okay. Okay, now the next is so the next is now example. So the example is find 2's complement, and maybe I just want to say, okay, for I don't want to write 2's complement because then you will know it is binary number. So just we can say find r's complement, r's complement of number. Number is now we have 1 1 0 1 1 0 0. Okay, this number we have. Now we don't know. Okay, just give you an idea. Okay, so if I say r's complement, you don't know. Still, you don't know. Either it is one, either it is two's complement, or it is ten's complement. You don't know yet until I define some base here. If I say 10, it means this is decimal number. If I say here 2, it means then it is 2's complement. Okay, so this thing is very important. Base is very important. So now here I am going to write 2. So when I write here 2, it means now we have to find here which one? 2's complement based on this base. Okay, this base. So now the solution is so now the solution is now so the solution is now from the question we can say r is 2, n is equal to 1 1 0 1 1 0 0, and our n is number of digits 1 2 3 4 5 6 7. So we have n is 7. Okay, now put in the formula. What is the formula for r's complement? The formula is r minus, sorry, R n minus capital N. So now put here, what is our R? So our R is now 2, N is 7 minus N. Now what is the rule for this one? How to write 2 power 7? So again, follow this thing. Follow this thing. 1 followed by n zeros. Okay. So then from this case, you can also do one thing, okay? 2 power 7, you can find in binary, okay? You can find in binary, okay? 2 power 7, maybe you can consider this is decimal number, okay? This is decimal. Then you can convert decimal to binary. Convert. Then you can find. So then if you can convert, then you can get R 2 power 7 is 1, and then 7 zeros, 1 2 3 4 5 6 7. So you can get this one. Then minus n. So n is now 0 0 1 1 0 1 1. So now the answer is from this case 0. It is subtraction minus 0. And now here you can see here, now we don't have, so we cannot do like 0 minus 1. So here, I mean here, this one. So we cannot do 0 minus 1 is equal to minus 1. We cannot do this one. So it means we need one borrow carry. So this one, so now, so this one will move here. So it is 1 0. So 1 0 means 2. So this 2 will move here. Then remaining here is 1. So this is again 2. So because 1 is 0, then this one move here. So it is again 2, and this one 1. Then this 2 move carry here. It is again 2. Remain 1 here. This 2 move here. So it is again 2, and this one is 1. This one move, oh sorry, we go very far. Yeah, so this one is 1. So now this 2 minus 1 is 1. Okay, 2 minus 1 is 1. Then you can see now this 1 minus 1. 1 minus 1 is 0. 1 minus 0 is 1. Then 1 minus 1 is 0. Then this red one 1, this 1 minus this 1 is 0. So this is our answer. So this is our answer. So this is our answer. Now the thing is this one, maybe we can say this is the method 1. Solution with method 1. Now let's suppose if I want to just show you method 2. So method 2 is, we can do Rn minus 1 minus n, then plus 1. Okay, and now I already told you, this means that this overall means that this is 1's complement, right? This is 1's complement. So it means if you add 1's complement, 1's complement plus 1, this is your 2's complement. This is your 2's complement. So now the question here is, we have this number. So now we can take this number here. So then we can say the number is now, so we can find now 1's complement, okay? 1's complement. So 1's complement is now, it is 1 because 0, then again 0, 1, then 0, then again 0, then 1, then 0, then 0. So this is the 1's complement. Now add plus 1 here. So now when you add 1 plus 1, so 1 plus 1 is 2. Okay, hope you know 1 plus 1 is 2. So 2 minus 1, subtract minus 1 from the base. So this is 1. Then 1 carry here. Then 1 plus, sorry. So this is 1 plus 1, it is 2. So 2 minus from the base, it is 0. So 0 here and 1 carry above. Then again 1 plus 1 is 2, 2 minus from the base. Then it is again 0. Then 1 carry here. So 1, it is come 1. Then 0, then 1, then 0, then 0. So this is your now 2's complement. So this is now your 2's complement. And now you can see now this one and this one is the same answer. Okay, is the same answer. So this is how we can find our r's complement and how we can find our r minus 1's complement. Okay. So this is now you learn how we can find diminish radix complement and how we can find radix complement. Okay. So any one of you have any question here? Otherwise, we can move to the next one. Anyone have a question?
No, Ajay.
No, Acha.